So now we will see the how to implement these best practices in API security testing and how to use and what are these open source tools we have to validate these best practices. So first of all, API security testing is essential for ensuring that the APIs are secure against attacks and vulnerabilities. So here are some best practices for API security testing and some open source tools that can be used to validate them. First one, we have authentication and authorization testing. The API for proper authentication and authorization to ensure that only authorized user can access the API. Open source tools such as OAuth Zap, Burpsuit, and Postman can be used to test the authentication and authorization. Authentication is the process of verifying the identity of a user or an entity trying to access the API, while authorization is the process of granting access only to those users or entities that have required permissions. So in API authentication testing, we need to ensure that the API requires authentication and only authenticated users are able to access the API. This can be done by testing the API with invalid credentials, incorrect passwords, or with no credentials at all. You can use open source tools such as WhatsApp, Burpsuit, and Postman to test API authentication. In API authorization testing, we need to ensure that API grants access to only those users or entities that have the required permissions. This can be done by testing the API with different roles and permissions and verifying each role is granted access only to the resources that is authorized to access. You can use open source tools such as WhatsApp, Burpsuit, and Postman to test API authorization. In addition to the above, there are several other aspects of API authentication and authorization that you should test for. These include first one we have session management. Ensure that API handles sessions securely and invalidates session after a period of inactivity or when the user logs out. Second one, password policies. Ensure that the API enforces strong password policies such as password complexity, password expiration, and password history. Multi-factor authentication. Test whether the API supports multi-factor authentication and ensure that multi-factor authentication is enforced for all high-risk actions. Token management. Ensure that API uses secure token management practices such as token expiration, token revocation, and token refreshing. So overall, testing authentication and authorization is crucial to ensure that only authorized users are able to access the API and that the data remains secure. So by choosing open source tools such as Zap, Burpsuit, and Postman, we can effectively test authentication and authorization to ensure that our API is secure. So next one we have input validation testing. So validation of input data to ensure that only valid data is accepted by the API. Open source tools such as Zap, Burpsuit, and SonarQube can be used to test input validation. It involves testing that the API to ensure that it validates and sanitize all input data to prevent malicious input that can lead to security vulnerabilities such as injection attack, cross-site scripting, that is XSS attacks, and buffer overflows. So to perform input validation testing, testers must send various types of input data, including valid type and invalid also, and malicious data to the API and verify that the API responds correctly to each input type. Here are some steps that can be followed to perform input validation testing. First, identity and input field. So the first step is to identify all input fields in the API, including parameters, headers, and cookies, and develop test cases. So based on the identified input fields, develop test case that can include different types of input data such as valid data, invalid data, and malicious data. Test for expected behavior. So for each input type, the test for expected behavior of the API. For example, if the API accepts a valid email address, test it with a valid email address and verify that the API accepts it. Similarly, if the API accepts an integer value, test it with an integer value and verify that the API accepts it. So test for unexpected behavior also. So test the API with unexpected inputted data such as invalid data or malicious data and verify that the API responds correctly. For example, if the API expects a string input but receives an integer, test it and verify that the API returns an error message indicating that the input is invalid. Test for boundary values. So test the API with input data that is at upper and lower limits of the acceptable range to ensure that the API behaves correctly. So for example, if the API accepts a number between 1 and 10, test it with 1 and 10 to verify that the API accepts both value. So open source tools such as Zap, Bubsuit can be used to perform input validation testing. These tools can automatically generate and send input data to the API and verify the responses. Additionally, SonarQube is a static code analysis tool that can identify potential input validation issues in the API code. So overall, input validation testing is an essential step in API security. Testing to ensure that the API properly validates and sanitizes input data, preventing malicious input from compromising API security. And the next one we have API rate limiting testing. So it tests the API for rate limiting to prevent DDoS attacks and limit the number of requests per second. So open source tools such as Apache, JMeter, and Gatling can be used to test API rate limiting. So API rate limiting is a technique used to limit the number of requests an API can handle in a given time. So it's security feature designed to prevent DDoS attacks, protect against abusive usage of the API, and ensure that the API's performance is not degraded due to excessive traffic. To test API rate limiting, you can use open source tools such as Apache JMeter and Gatling. So these tools allows you to simulate traffic to the API and test how it handles request when it is under a heavy load. So to test API rate limiting using Apache JMeter, so you have to follow these steps. So after the installation and configuration of Apache JMeter on our local machine or server, create a test plan by adding a new thread group to the test plan. Add HTTP request sampler to the thread group and configure it to send request to the API endpoint. So add a timer element to the HTTP request sampler to simulate a delay between requests. So configure the HTTP request sampler to send multiple requests per second to the API endpoint. So run the test and monitor how the API handles the request. So after that, analyze the result to see how the API performs under load and whether it properly enforces rate limits. So similarly, to test API rate limiting using Gatling, so the following steps are: after the installation and configuration of Gatling on a local machine or server, create a scenario by defining the sequence of action that the virtual users will perform. Add an HTTP request to the scenario and configure it to send request to the API endpoint. Use the pause method to simulate a delay between requests. So configure the virtual user to send multiple requests per second to the API endpoint. Run the test and monitor how the API handles the request. So analyze the result to see how the API performs under load and whether it properly enforces rate limits. So API rate limit testing is an important aspect of API security testing. Open source tools such as JMeter and Gatling can be used to simulate traffic to the API and test how it handles requests under heavy load. So by performing API rate limiting testing, you can ensure that the API can handle traffic effectively while protecting against DDoS attacks and abusive usage. And the next one we have HTTPS and SSL TLS testing test the API for proper implementation of HTTPS and SSL TLS to ensure that the data is encrypted during transmission. So open source tools such as SLIs and Nmap can be used to test HTTP and SSL TLS. So HTTPS, that is Hypertext Transfer Protocol, is secure. So is an extension of the HTTP protocol that uses encryption to secure data transmission. SSL and TLS are cryptographic protocols that provide secure communication over the internet. So SSL was the predecessor of the TLS and is not deprecated. So HTTPS and SSL TLS are critical to ensure the security and privacy of data transmitted between the API clients and the API server. So they prevent unauthorized access, interception, and tampering of sensitive data transmitted over the internet. So here are key aspects of HTTPS and SSL TLS testing that you should consider when you're testing your API. First one, your certificate verification. So we have to verify that the SSL TLS certificate is valid and issued by a trusted certificate authority. An invalid or self-signed certificate can make your API vulnerable to the man-in-the-middle attacks. Encryption strength. We have to verify the encryption strength of the SSL TLS connection. The encryption strength is measured in bits, and the higher the number of bits, the stronger the encryption. So now we have to verify the SSL TLS protocol version used by the API is up to date and secure. Older versions of SSL TLS such as SSL v2 and SSL v3 have known vulnerabilities. Now we have to verify the API is not serving mixed content over HTTPS. Mixed content refers to the web page served over HTTPS that contains insecure content such as images, script, and style sheet served over HTTP. HSTS implementation. Now we have to verify the HTTP strict transport security, that HSTS header is implemented correctly. HSTS forces the client to always use HTTPS to communicate with the API, even if the user tries to connect over HTTP. See, to perform HTTPS and SSL TLS testing, you need to use open source tools such as SSLIS and Nmap. These tools can scan your API for SSL TLS vulnerabilities and provide detailed reports on the encryption strength, certificate validation, and protocol version. You can also use a web browser extension such as HTTPS Everywhere to force HTTPS on all websites and API calls. So next we have security testing headers. So now we have to test the API for proper implementation of security headers such as content security policy, that is CSP, and XSS protection. Open source tools such as Zap and Burpsuit and securityheaders.io can be used to test the security headers. So security headers are HTTP headers that provide instruction to the web browser on how to handle certain security related aspects of the web application. So they are used to protect the web application from various types of attack, including cross-site scripting, clickjacking, and MIME type sniffing. So CSP is a security header that is used to mitigate XSS attacks. It specifies the types of content that the browser is allowed to load and the sources from which can it load them. By doing so, CSP prevents attackers from injecting malicious script into the web application, thereby protecting the user's data and sensitive information. XSS protection is another security header that is used to mitigate XSS attacks. It enables the browser's built-in XSS filter, which attempts to detect and prevent XSS attacks by blocking malicious script from executing. To test the implementation of these security headers, open source tools such as Zap, Burpsuit, and securityheaders.io can be used. These tools can be used to check if the security headers are present, correctly configured, and provide adequate protection against known vulnerabilities. So Absorb and Burpsuit are powerful web application security scanners that can use to automate the process of testing security headers. They can identify and report any missing or misconfigured security headers and provide recommendation on how to fix them. Securityheaders.io is an online tool that can be used to check the implementation of security headers. It allows users to enter the URL of the web application and generates a report on the implementation of security headers. It also provides recommendations on how to improve the security headers to enhance the overall security of web application. So in summary, testing for the proper implementation of security headers is crucial in ensuring the security of API. So by using open source tools such as Zap, Burpsuit, and securityheaders.io, developers can validate the implementation of security headers and ensure that they are configured correctly to provide adequate protection against known vulnerabilities. So next one we have API vulnerability scanning. So it performs regular vulnerability scan for the API to identify the fixed vulnerabilities. Open source tools such as Zap, Archini, or OpenVAS can be used to perform API vulnerability scanning. So vulnerability scanning is an automated process of identifying potential security weaknesses or vulnerabilities in the system or application. In the context of API security, testing vulnerability scanning involves scanning the API to identify vulnerabilities in the code, configuration, and infrastructure. Vulnerability scanning can be performed using open source tools such as Zap, Archie, and OpenVS. These tools are designed to identify vulnerabilities such as SQL injection, cross-site scripting, and authentication bypass. They can also detect vulnerabilities in the SSL TLS configuration, insecure cookies, and weak password. So to perform a vulnerability scan of the API, the following steps can be taken. First, we have to identify the scope of the scan. Identify the API that need to be scanned and the parameters to be tested. Configure the vulnerability scanning tool. So now we have to configure the tool to scan the API based on the scope identified in the step 1. The tool should be configured to use the appropriate scanning techniques based on the type of API being tested. Next one, we have to run the scan and monitor the progress. The scan may take several minutes to complete depending on the size of the API. Now we have to review the result of the scan and prioritize the vulnerability based on their severity. Some tools provide detailed reports with recommendation for remediation. Next, we have to fix the identified vulnerabilities and perform a rescan to ensure that they have been resolved. So vulnerability scanning should be performed regularly as a part of API security testing process. This will help to ensure that the API is secure against known vulnerabilities and that any new vulnerabilities are identified and fixed in a timely manner. So next we have API security auditing. So it performs regular security audits of the API to ensure compliance with security policies and standards. Open source tools such as WebZap and Burpsuite can be used to perform API security auditing. So API security auditing is an essential part of the API security testing process as it helps to identify security vulnerabilities and weaknesses that may have been missed during other security testing activities. An API security audit typically involves reviewing the API security controls, policies, and procedures to ensure that they are in line with industry standards and best practices. The following are some of the key steps involved in conducting an API security audit. So here we have to identify the scope first. So the first step in an API security audit is to identify the scope of the audit, including the specific API endpoint, function, and data that will be audited. Next, we have to review the security controls. The next step is to review the API security controls, including authentication and authorization mechanism, input validation procedures, data encryption and data decryption methods, and access controls. Next, we have to evaluate the compliance with standards. The API should be evaluated against industry standards and best practices such as OAuth API Security Top 10, NIST Cyber Security Framework, and ISO IEC 27001 to ensure that it meets the necessary security requirements. Next, we have to identify vulnerabilities and weaknesses. The API should be tested for security vulnerabilities and weaknesses such as injection attacks, broken authentication, and session management, cross-site scripting, and cross-site request forgery. So once the vulnerability and weaknesses are identified, the audit team should recommend remediation measures that address the identified issues. After the remediation measures have been implemented, the audit team should follow up to ensure that the issue have been adequately addressed and that the API is now compliant with security policies and standards. So API security auditing involves a comprehensive review of the API security controls, compliance with industry standards and best practices, identification of vulnerability and weaknesses, and the recommendation and follow-up of remediation measures. It is a critical step in ensuring that the API is secure against potential threats and vulnerabilities. To summarize, the best practice for API security testing include authentication and authorization testing, input validation testing, API rate limit testing, HTTPS and SSL TLS testing, security header testing, API vulnerability scanning, and API security auditing. So open source tools such as Zap, Burpsuite, Postman, Apache JMeter, Gatling, SSLIs, Nmap, and securityheaders.io, Arachne, and O1VS can be used to validate these practices.